about the exercise 1.4 on differentiation. This is called as parametric form. We will try to do, there are four major questions. We'll try to do one or two questions from each type. Let's start with the first type. Now what it does is, let's take this first question of x is equal to at square and y is equal to 2at. Here x is given in terms of a third variable t, y is given in terms of third variable t. What we need to do is, we need to first find out dx by dt. Now when you differentiate x with respect to t, a is a constant and differentiation t square with respect to t is 2t. This is called as 2at. Similarly, y will differentiate it with respect to t. We get dy by dt is equal to 2a and derivative of t is 1. So which is 2a. Now once you have your dy by dt and dx by dt, it's pretty simple. The parametric says that dy by dx is equal to dy by dt upon dx by dt. You will have to write dy by dt, which is 2a, upon dx by dt, which is 2at. We will cut this 2a, we will get 1 upon t. This is called as parametric form. So first you differentiate x with respect to t, you differentiate y with respect to t, you get dx by dt, dy by dt. You divide the two, you get dy by dx. So remember this is a basic form of a parametric. Let's try and do another question. Now the second question, let me remove this as of now. Now the second question we can do is, let's take x is equal to, you can 1, 2, 3, 4, 5 are of similar type. Let's try to take either 6 or 7. Now let's take 7 question. 7th question is, x is equal to cos inverse of 2t upon 1 plus t square and y is equal to sec inverse of root of 1 plus t square. Now if you can see in both questions, now this is slightly complicated question in the parametric one. Here it is of the form of 2t upon 1 plus t square, and here it is form of 1 plus t square. Now I'll have to substitute something. Suppose I take t is equal to tan theta. And I know that this first term will become 2t, which means 2 tan theta upon 1 plus tan square theta, and which we know that is sine 2 theta in trigonometry. Similarly, if we put this t in this second y wala part, where it is root of 1 plus t square, which will become root of 1 plus tan square theta, which is root of sec square theta, which is sec theta. Now we need to substitute these two values of sine 2 theta and sec theta in the original question. So x will become cos inverse of sine 2 theta and y will become sec inverse of sec theta, which means y will be equal to theta. Now if t is equal to tan theta, we can also write theta is equal to tan inverse of t. So your y is tan inverse of t. Here we can write x is equal to cos inverse of cos 90 minus theta. So it will become cos 90 minus 2 theta. Here again cos and cos will get cut. You will get x is equal to 90 minus 2 theta. Whereas theta is again tan inverse of 2 t. Now we have got x and y. If you want to differentiate this dx by dt, you will get constant will be 0 minus 2. This will be 1 plus t square. Derivative of tan inverse of t is 1 upon 1 plus t square. Similarly, dy by dt is equal to derivative of tan inverse of t, which is 1 upon 1 plus t square. Now when you differentiate this, you get both. You divide one by other, dy by dt upon dx by dt. You will get dy by dx as equal to, you can get dy by dx equal to dy by dx will be equal to 1 upon 1 plus t square upon minus 2 upon 1 plus t square. This will get cut. This will be equal to minus 1. So this is how this kind of a question can be done. Similarly, try to do the eighth question by taking an example of t as sine theta. Practice this, you will get that. Let us try and do a second question now. In the second question, it is the similar type of a question is there, but in this type, we will have a value to be found out after that. So some theta is given. So first we solve the question and then we substitute the value of theta. So let's take an example of first question where x is equal to cosec square theta. Now it is as function square. So dx by d theta will be equal to 2 cosec theta, because function raised to n, 2 into function into derivative of cosec theta, which is minus cosec theta cot theta. Similarly, your y will be given as cot cube theta. So you can write dy by d theta will be 3 cot square theta into derivative of cot theta. What is derivative of cot theta? Minus cosec square theta. Now this is how you have got an answer. You have dy by d theta, dx by d theta. You have to find out dy by dx. Dy by dx, you will divide the second equation by first equation. So we will get dy by dx is equal to 3 into cot theta into minus cosec square theta upon 2 into cosec theta into minus cosec theta into cot theta. So you can see this cot theta will get cut. This minus cosec square will get cut. You will get only 3 by 2. So here, I don't think the value of theta is required to be put, but if you would have got some answer in terms of theta, we'll just check once again. Cosec square theta is equal to 2 cosec theta into derivative of cosec theta is minus cosec theta cot theta. Whereas derivative of cot cube theta is, this is 3 cot square theta. So there will be 3 cot square theta. So when you cut, you still get 1 cot theta. So the final answer is 3 by 2 cot theta. This is the final answer. Now here you put the value of theta. So you get 3 by 2 cot pi by 6. Theta is given as pi by 6, which means cot 30. Now tan 30 is 1 upon root 3. So cot 30 will be root 3. Your answer will be 3 root 3 upon 2. This is how this question needs to be done. Similarly, you can do second and third questions. Let me just take one more question of this type. Let us take the fourth question. The fourth question is equal to x is given as 2 cos t plus cos 2t and y is given as 2 sin t minus sin 2t and t is given as pi by 4. Now if I differentiate dx with respect to t, I get dx equal to minus 2 sin t minus, now cos 2t is minus sin 2t, but there is an additional 2 of derivative. So minus 2 sin 2t. Similarly, dy by dt will be equal to derivative of sin t is cos t. So 2 cos t minus derivative of sin 2t is cos 2t and 2 cos 2t. Now we have to find out dy by dx. We will divide both the equations. We get dy by dx equal to dy by dt upon dx by dt, which is 2 cos t minus 2 cos 2t upon 2 sin t minus 2 sin t minus 2 sin 2t. Now if I take 2 common on both, I will get it as cos t minus cos 2t upon sin t minus sin t minus sin 2t. This is the but this is derivative. We have to find out dy by dt at t is equal to pi by 4. So we will write dy by dx at t is equal to pi by 4. We will substitute the value of t as 45 or pi by 4. So cos pi by 4 minus cos 2 pi by 4 is pi by 2 upon minus sin pi by 4 minus sin pi by 2. Now we know that cos pi by 4 is equal to 1 by root 3. So we can write 1 by root 2, sorry, minus cos 90 is 0. Sin pi by 4 is 1 upon root 2 minus sin 90 is 1. So minus 1. So you will get 1 upon root 2 upon minus 1 minus root 2 upon root 2. This will get cancelled. Answer will be 1 upon minus 1 minus root 2. Please check this answer once. So that's how the second question needs to be done. Let's try, and now let us move on and try to do the third question. In the third question, let's take the first example, which is x by x is equal to a root of sec theta minus tan theta, and y is equal to root of sec theta plus tan theta. And we have to prove dy by dx is equal to minus y by x. So in this question, what we will do is we will try to get this up. We will try to zoom out first, and we will collect this entire thing, and we will move it further so that you all can see this. Now, in this question, once we collect this entire thing, we move it up, we will get this. Now, here in this question, what we need to now do is need to zoom in and see. Now, x is equal to root of sec theta. So this will become what? This will become x upon a is equal to, because x is equal to root of this, so this will become x upon a is equal to root of sec theta minus tan theta, and y upon a is equal to root of sec theta plus tan theta. Then we will square on both sides. Once you square on both sides, you'll get root out. This will become sec theta minus tan theta is equal to x square upon a square, and this will become y square upon a square is equal to sec theta plus tan theta. After that, after we square these two, we will add these two first. So we get sec theta and sec theta, tan theta gets cancelled. We get 2 sec theta is equal to x square upon a square plus y square upon a square, which can be further written as x square plus y square upon 2a square equal to sec theta. Similarly, we will subtract these two terms and we will get rid of sec theta. We will get 2 tan theta is equal to y square minus x square upon 2a square. Once we get these two terms of sec theta and tan theta, we need to eliminate theta. So we need to remember that sec square theta minus tan square theta is equal to 1. And we will substitute the value of sec theta as x square plus y square upon 2 square minus y square minus x square upon 2 square, the whole square equal to 1. Now we have got rid of theta. We have got, now we will open it as a plus b the whole square. We will get it as x raised to 4 plus y raised to 4 plus 2x square y square. So this is like this. Similarly, we will write here y square plus x raised to 4 minus 2x square y square. And this term will go that side. So it will become 4a raised to 4 LCM of. So this will go that side. Now, what is the next step? Next step would be, we will be solving this further. We will open this bracket, this 2xy, this will come, this x square, x raised to 4, x raised to 4, y raised to 4, y raised to 4 will go. We will have 4x square y square is equal to 4a raised to 4. Again, the 4 will get disconnected. Actually, this will not come as 4. This will come as 2a raised to 2 square. And this will become 2a raised to square. Then you can solve x square y square equal to constant. You will differentiate. You will get x square into derivative of y square plus y square into derivative of x square, which is x square into 2y dy by dx plus y square into 2x equal to 0. You will get 2. You will cancel xy. You will get dy by dx equal to minus y by x. So this is how this particular term, so this 2a, sorry, this will become 4a square a raised to 4 only, because there's an entire square here. So 2a square is equal to 4a raised to 4. Now, this is how you prove this. Let's take one more question. We can delete this question and we will take question number, and take one more question. Say we have question number 8. Now 8 is also similar to what we did in the previous exercise. X is equal to 2bt upon 1 plus t square. Y is equal to a into 1 minus t square upon 1 plus t square. So whenever you see 1 upon 1 minus t square implies, we have to substitute t as tan theta. So if you take t as tan theta, you will get 1 minus tan square theta, and 1 plus tan square theta will be equal to cos 2 theta. Also here 2 tan theta upon 1 plus tan square theta is equal to sine 2 theta. These two things you have to remember, sine 2 theta, cos 2 theta. We will substitute here. X will become 2b sine 2 theta, whereas y will become a into cos 2 theta. Now if I have to differentiate it further, I can write dx by d theta is equal to 2b 2 cos 2 theta, whereas we can write dy by d theta is equal to a into minus 2 sine 2 theta. Minus 2 sine 2 theta. If I divide dy by d theta upon dx by d theta, I will get dy by dx, 2 will get cancelled, and I will get minus sine 2 theta upon 2b cos 2 theta, which is equal to tan 2 theta, which is equal to tan 2 theta minus tan 2 theta upon 2b. But minus tan 2 theta is t, so this is minus tan 2 theta will be, theta is tan inverse of t, so this will become minus tan 2 tan inverse of t upon 2b. This is how you can solve this question. But what we have to do is we have to prove that dx upon dy is equal to minus b square y upon ax square. So you can further try substituting the values, which means when you got dy by dx, what you could have done here is, instead of putting sine 2 theta value, you can put as x upon b. You can put here x upon 2b as sine 2 theta. Cos 2 theta is y upon a, and in denominator it is 2b, and cos theta is y upon a, which goes up. So it becomes something like minus x into a upon y into b square. Something of that sort will come, and further minus x into a, I think there is to be some cos theta. I think some a or something, you'll have to check that and you will match that answer. That is how it needs to be done. Now let us try and do the last part, the fourth exercise, fourth question. So in the fourth question, let us see what is given. In the fourth question, you have to differentiate x with, so this is pretty simple, not much complicated. What we will have to do is we will have to first differentiate the first term with respect to the second term. So instead of given as y and x, till previous question a y term was given and x term was given, we used to differentiate this with respect to t, this respect to t, and then we used to divide the two. Here when they write, let me take the fifth question. When they write differentiate 3 raised to x, So y is equal to 3 raised to x with respect to something. So instead of, so let's take this as t. So here it is log of 3 to the base x. Now y is given in terms of this, t is given, and we have to find out dy by dx, and then we have to find out dt by dx, and then we have to divide and find out dy by dt. So let me first do dy by dt. Dy by dt will be equal to a raised to x, 3 raised to x into log a, which is log 3. dt upon dx can be written as, first you have to write this t is equal to, since this log 3 is to the base x, you can write t is equal to log of a upon log of b. So log of 3 to the base upon log of x. Now dt upon dx can be written as log of 3 can be written as constant into derivative of 1 upon log of x. Now this is 1 upon a function, which is minus 1 upon log x square into derivative of log x, which is 1 upon x. So that is dt upon x. Now what you have to do is, you have to differentiate, you have to do dy by dt is equal to dy by dx upon dt upon dx. So this will become dy by dx is 3 raised to x log 3 upon minus 1 upon x into log x square, which is equal to, which will go in the numerator, it will become minus 3 raised to x log 3 into x into log of x square. This is how, this is the final answer. Similarly, you can practice the other questions, and the questions like these, question number 2 and all, where you have 2x upon 1 plus x square, 1 minus 3, you have to put x as tan theta here, so that this becomes sine 2 theta, this becomes cos 2 theta, and then it is substituted. Similarly, here you'll have to put x as tan theta. So all these questions can be done by substituting. Wherever 1 minus x square is there, try to put sine theta. Wherever 1 plus x theta x is there, try to put tan theta, so that it becomes sec square theta. To practice these questions, any doubt, I can take it up. Thank you so much. Do subscribe to our channel.